And we are here, we are back again. We have looked at a group of people that do not have a disease, but there is some disease outbreak somewhere. We were using the example of China, where we had the COVID-19 originating from the virus itself. The susceptibles, they get infected and they recover. The population is remaining constant. So we are sure about one thing, that the rate at which n changes with respect to time is equals to zero. So this is our model. We have created these compartments, and you are going to realize that in epidemiological studies, in disease modeling, most of the times you are going to be working with those compartments. Like I said, at one particular point in time, you can extend those compartments to include so many other things. So now, what do? We have got the model. We need now to show some mathematical components about the model. We need to prove that the solutions are always going to be positive, because if we find that after some time, 2 years, we have got minus 5 people with COVID-19. That is meaningless, because what is negative 5 people? So we need to show that our solutions are going to be positive. We need to show that they will always be positive. So that's the other thing that we need to always show. And so we are going to look at those mathematical aspects. So that's the beginning of the analysis. Of course, we are going to look for a point whereby we live with the disease and the disease lives with us and we are okay. So we are also going to be interested in the point where there is no disease at all, because that is ideal. That is what every government is looking for, a point where there is no disease. And we are also going to be interested in how we can actually eradicate the disease. What are the conditions for eradicating the disease? So that is part of the analysis that is left. And once we are done with that, then we look for our data, and then we feed the data into the model to see now if what we are saying and claiming, the model fitting the data. So we are going to test and validate our model in that particular way. So let's proceed now and look at the concept of mathematical model analysis, mathematical analysis of the model, and see if we can get something out of that. And I want you to know that it is important to remember that as the model becomes bigger, things also change. They become a little bit more complicated. So this is the simplest form that we can discuss, the basic simple SIR model, but there are bigger models out there, some with even 10 compartments, 13 compartments, but still we must be able to apply the same ideas. All right.